Hello everybody. In this video, I want to bring what we've learned about stoichiometry and moles and balancing equations together to answer more real-world problems that chemists are really going to face anytime that they're working in the lab or at the bench. So in the real world, we have no direct way of knowing how many moles of reactants we have or how many moles of product we produce. It's just no machine that reads out moles. What we can measure, however, is mass. And so what we're going to do typically is we're going to take a mass measurement. We'll convert that over to moles using the formula weight, formula mass. We'll perform any stoichiometry that we need to get to some other part of the reaction, some other reagent or product. We'll then have the moles of that after using our stoichiometric factors, and then we'll convert that back over to mass, which is a measurable quantity that we can compare our results to. So let's look at a problem where we do just that. In this example, we're being asked what mass of hydrogen gas will be produced by reacting 1.000 grams of magnesium with an excess of hydrochloric acid. And here we have a balanced reaction for it. You can see that we're going to have 2 moles of HCl for every 1 mole of magnesium that's going to react. And we're going to be producing 1 mole of H2 gas. And then we're going to have magnesium chloride as our other product here. Step 1 for solving this problem, we need to go from the mass that we were given to the moles that represents. So we were told that we were going to react 1.00 grams of magnesium. We can go to our periodic table and look up the atomic mass of magnesium. We know that it's 24.305 grams. We know that that is an AMU, but that's equivalent to grams per mole, so we can use that as a conversion factor here. We're going to cancel our grams, and we're going to now be in moles, and we can see that that is 0.04114 moles of magnesium, or 4.114 times 10 to the negative 2 moles of magnesium. The next thing we're going to do is we're going to go from the moles of magnesium to the moles of hydrogen gas. And if we look at our equation here, we can see that we're going to produce 1 mole of hydrogen gas for every 1 mole of magnesium. So we go from 0.04114 moles of magnesium. We'll write in the magnesium here so that we don't forget. And we're going to make our conversion here. So 1 mole of H2 for every 1 mole of magnesium. That's easy math. We've canceled that moles of magnesium. And we get 0.0414 moles of H2. Now the final thing that we wanted is not to know the number of moles of H2 that we're going to produce, but the mass of H2 that we're going to produce. To do that, we need to multiply it by its molecular weight. We'll cancel these moles of H2. We'll multiply by the 2.016 grams, and we get a total amount of 0.08295 grams of H2.